So the methods we're going to use assume that always the right-hand side of the equation is 0. So that's the first thing I do if I have an equation to solve. And if you think back to a minute or two ago, we had this simultaneous equation where the right-hand side, I think, was 6 or something. I'd get that over the other side so that the right-hand side was 0. If I was going to plot this graphically, I'd plot something like this. Y equals this, and then see where it cuts the x-axis. This is a general quadratic. In other words, my equation looks a bit like this quadratic equation, the left-hand side does. There's some term involving x squared, that's what makes it quadratic, and this a represents a number that's in front of it. So this is what's called the coefficient of x squared, this a. It could be positive, it could be negative, it could be a fraction, any number. So some number in front of the x squared. There could be a term involving x. There may not be a term involving x, in which case that's gone, but there could be. So there could be a term involving x, and then there will be a number in front of that x, which will be its coefficient. And there could be a number, c, a constant. So if you think about it, this covers all possibilities for a quadratic. If it's quadratic, there must be an x squared term, and there also might be a term involving x, and there also might be a number which hasn't got x in it at all. There can't be anything else. If there was another one like x cubed, well, then it wouldn't be a quadratic anymore. So this is all the possibilities for a quadratic equation. So if we can come up, as we will do, with a way of solving a general quadratic like this, then we can solve any quadratic. One way is to rearrange the equation so the right-hand side is 0, and then into the autograph type y equals that. And then you're looking for when y equals 0, because that's where it cuts the x-axis. And so your solutions are here and here. So that's one way to do it. Just look for where it cuts the x-axis. 2 solutions, remember. Another way is to solve it algebraically. And there's 3 ways. One, when there's no constant. So solve it if there's no c. One where there's no term involving x. And one where you've got all 3. So we're going to look at those now. The first one, the first scenario, is when b equals 0. In other words, there's no term involving x. You've just got a general quadratic that looks like that. ax squared plus c equals 0. So, for example, 16x squared minus 20 equals 0. But I could pick any number. So what do? Well, I treat it like any equation. Add 20 to both sides. In this scenario, right-hand side equals 0, but to solve it, add 20 to both sides, whoops, equals 20. Divide by 16, x squared equals 20 over 16. X, to get x square root, x equals the square root of 20 over 16, and that's literally what I type into the calculator. So I'd use the fraction button, square root of 20 over 16 to get the answer. X equals plus or minus 1.12 to 3 significant figures. Check on your calculator. Don't forget, the calculator doesn't tell you it's positive or negative. You have to remember that. 2 roots. So if I've got a situation where there's no term involving x, straightforward, treat it like an ordinary equation. Get the number on the right-hand side and then solve it. What about this one? What would I do here? First step, minus 16 from both sides. Now what? Square root it. Now calculator. Doesn't like it. The calculator doesn't like it. You cannot have the square root of a negative number. If you think about it, it's always going to have to be positive. So there may be situations where you cannot solve quadratic equations, and we're going to talk about that. The solution to that problem actually turned out to be a really powerful branch of mathematics that you've done with me already if you've done the BTEC. The idea of complex numbers and imaginary numbers. But we're not talking about that quite yet. Okay? So with that in mind, be careful. If you've got a negative when you come to the root at the end, you've either made a mistake or there's no solution. So that's the way we go with these quadratics if there's no term involving x.